Hey, you guys. Yes, another basic chem video from Mrs. Horner. And this video is going to be on classification of matter. Classification of matter. Well, first off, matter is anything that has two very important characteristics. Matter is anything that occupies space, notice I've got the N there, sorry, anything that occupies space, and that's, by the way, that's called volume, and plus has mass or a quantity of matter. Okay, so when we talk about matter in general, matter itself is anything that occupies space and has mass. But we like to look at matter as like, what kind of matter is out there? Everything around us is matter, from the air that we breathe, to the table that we're leaning on, to the parts in our body, to like the water that we drink. Everything is matter because it occupies space and has mass. But we do like to classify it. And so when we look at this, we're going to do a nice little concept map here. We're going to talk about matter and how we can divide it into two basic groups. And those two basic groups are either pure substances or mixtures. Isn't it weird to kind of think that everything around us is either a pure substance or a mixture? Like, what is our table, for instance? What is the air we breathe? What is the water we drink? What is the silver in a silver coin? Like, what are all these things? Do they fall under pure substances or mixtures? Well, pure substances are anything that cannot be broken down by physical means. Cannot be broken physically. So if I can't separate it easily by physical means, then it's not a pure substance. And pure substances, we'll go into that like right now, really come in two forms. They come in elements, which we're going to find on the periodic table. Okay, they're on periodic chart. And compounds, which are made up of two or more elements, but they're chemically combined, so we can't physically break them. Okay, so two or more elements bonded together. Okay, and that's intra-bonds that we're talking about. Okay. So what are some examples? So I'm going to say something and then you try and think of it. I'll wait like a couple seconds and then you tell me what you think it is. Now I will give you a hint. When you think elements, think something that's found on the periodic chart. When you think compounds, I want you to think of a formula. Okay? So if I tell you something such as water, it's H2O. It has a formula. So water is a compound. So under this, we're going to write some examples. Water, H2O. Good old water has a formula. How about salt? We saw that last, and we know that that also has a formula. It's NaCl. But what about if I just said silver? Okay, silver can actually be found on the periodic chart, and it's Ag. Same with gold. Silver and gold. Okay, it's Christmas time, but had to sing that. Silver and gold are found on the periodic chart, okay? But so is another really common element, carbon. Ooh, and let us not forget to mention hydrogen, oxygen, nitrogen, and phosphorus. Why am I mentioning these? We just finished talking about biogeochemical cycles. These were the important elements. And these are the important elements we find in the compounds of life, such as some life has a lot of C6H12O6. Notice it has carbon, hydrogen, and oxygen in it. That is actually sugar or glucose. That's glucose. Remember, this was salt. And this is, of course, water. Okay. And there are going to be other things too, like hormones, saliva. These are all different like compounds because they actually have formulas. Don't ask me the formulas for all of these, but they're out there. Okay. Now let's go to our other side. Pure substances cannot be broken down physically. So that means mixtures can be separated, easily separated physically, easily physically separated physically. Okay, so this is mixtures. This was pure substances, our elements, and our compounds. And by the way, elements are represented. I'm sorry, this is kind of cut off at the bottom here. Represented with symbols. Okay, so like CHONPAGAU, they're all symbols. So is Na and Cl. But when we put them all together, compounds are represented by formulas. Okay, so mixtures. What are the kinds of mixtures out there? Well, there happens to be two types. We talk about homogeneous, and the prefix homo means same throughout, And we'll do some examples of that. And the opposite of that is heterogeneous. These two prefixes, hetero and homo, same and different, come up quite a bit in biology, okay? We don't snicker at these words. We don't get derogatory to these words. But just even talking about sexuality, homosexuality is usually between the same sexes. Heterosexuality is usually between two of different sexes, okay? So these are differing parts. Now, this is matter we're talking about here. Remember, we're not talking about people, okay? So homogeneous, what are homogeneous mixtures? What are heterogeneous mixtures? I'm going to break this out into a wider view to look at, okay? So let's look at the homogeneous that are out there first. Homogeneous mixtures come in two types again. And we'll mention the first type, which is called a solution. And I want you to think of the word dissolve when we hear of solutions, okay? One part dissolves in the other. The part that gets dissolved is called the solute, okay? And the part that does the dissolving is called the solvent. Water we often call the universal solvent because it dissolves so many things. So the solvent does the dissolving, while the solute is the one that gets dissolved. And those are the two parts of a solution, solute and solvent. So if I give you an example of a solution, let's say salt water, okay? What part of salty water is the salt? Is it the solute or the solvent? Right, it's the solute because the salt gets dissolved by the water. Another solution that you might not realize is air. Air has actually many substances within it, or many parts to it, but they're all dissolved within each other. Air has things like carbon dioxide, and it has things like oxygen, and the number one component of air is nitrogen, okay? And there's a lot of this stuff called argon too. Those are the three main things. Argon is just a little element there. Nitrogen is kind of like an element, but it's a kind of different kind of element, just like oxygen. They always have two with them. They can't be left alone. And carbon dioxide is definitely a compound there. And air is a mixture that's homogeneous. It's the same throughout. You don't walk through the hallway and suddenly run into a pocket of carbon dioxide and start suffocating, do you? Or run into oxygen and then you can really breathe. No, it's all dissolved throughout. And those are gases. Still yet another solution that I always like to talk about is soda water. Okay, soda is usually carbon dioxide and water. And then you can even add the sugar and the flavoring, okay? And they're all dissolved within the water. So the water is the solvent, carbon dioxide, sugar, and flavor are all the solutes. Now, it might be confusing, like which is the solute and solvent. When they're all gases like that, like in air, it's kind of hard to tell the difference of which one is what, okay? But that's a few solutions there. The other homogeneous mixture out there is called a colloid. These are very interesting and they're very important in biology. Colloids are, I want you to think of the word disperse. Disperse. Because what happens in a colloid is the particles don't quite all the way dissolve. So we don't have one part and the other part, like the one that disperses and the one that does the dispersing. Instead, we talk about the different types of colloids out there. And if you actually had a magnifying glass, you could see these things. And it's interesting. Some biologists call colloids homogeneous, but you'll see where when we talk about the heterogeneous mixtures, some people will classify colloids as heterogeneous. It's kind of like a interesting thing. Are they the same throughout? So let me talk about the different types. We can have sol colloids, which are kind of liquidy. And I'm going to say like raw egg white here, raw egg white. You know when you crack open an egg, okay, and it comes out raw, it's kind of like snotty and thick and everything. That's a colloid. Colloids are usually thicker in consistency, but colloids could also come in a gel form, and this is kind of more firm, okay? And if we take that raw egg white and we cook it, then we would get a gel. So I'm going to say cooked egg white here. Okay, so colloids come in two forms, a sol or a gel. One's liquidy, one's firm. But sometimes sometimes colloids can be what we call reversible, where it can go back and forth between like the sol and the gel. And a good example of that would be like Jell-O. Jell-O in its liquidy form, that's when it's hot, but then when you cool it, it gels and it gets jiggly, right? That's a reversible colloid. But our egg white is what we call irreversible. Irreversible go one way and then they don't go back. So in the case of like raw egg white, it's like a sol forms a gel when you cook it. So like egg raw goes to egg cooked, okay? And when it's raw, it's liquidy, but when you cook it, it firms up, but it can't go back. It's one way. It's irreversible, okay? And that's your colloids, all right? Finally, your definite heterogeneous mixtures are what we call our suspensions. And a lot of things out there are suspensions, okay? A suspension, you definitely can see a difference. I like to think of, you can see the separate parts. And a good example of that is a granite countertop, granite. You know how like if you look at a granite countertop, you see all the little speckles of different things? That's because it's actually a suspension. Another example is like sand and water. Sandy water. The sand eventually settles out. Still another one is a good old salad out there. You know how you can see like the separate like croutons from the lettuce, from the carrots, from the tomatoes. These are all suspensions. So that's it for like our types of matter. And going back to the first page, matter comes in either pure substances or mixtures. Pure substances are either elements found on the periodic chart or compounds that have formulas. And mixtures, which are either homogeneous, which are the same throughout, and they can be solutions and colloids, depends on who's teaching you this. Some people say colloids are homogeneous, some people say they're heterogeneous. Think dissolve or disperse, okay? And suspensions, which definitely you can see the separate parts in, okay? And that's it for this video on types of matter.